Greetings to all. Myself Dr. B. Pratap Reddy. I am working as a DST Inspire faculty at the Department of Electronic Systems Engineering, Indian Institute of Science, Bangalore. The course title is Design of Electric Motors. The course outcomes we can see here: the analysis and design of basic magnetic circuits with and without air gaps. For example, how to design the electromagnet for door locking system, or how to design the inductors for various applications like power converters, etc. The realization of conventional machines from the basic principles of electromagnets. Then the design of electrical machines for any type of applications with respect to the sizing equations and magnetic loading, electric loading, geometry equations with respect to the stator core and rotor core, and torque, power density, speeds, efficiency, performance parameters, etc. we will discuss in detail, and the scope for designing and realization of new type of machines. The week wise syllabus of this course is as follows. Week 1 and week 2 will discuss the review of magnetic circuits, where the electric fields and magnetic fields will discuss. For a positive charge, electric fields will be outward direction. For a negative charge, the electric fields radially inward direction. Then the magnetic field sources with respect to the current in a wire, loop of a wire, solenoid with air as a medium, and electromagnet with some iron material as a medium, bar magnet, and the earth. So, the electromagnetic laws related to the electric fields and magnetic fields like Ohm's law, Ampere's law, Faraday's law, thumb rule, Fleming's left hand and right hand rules we will discuss in detail. Later, the magnetic materials and BH curves we will discuss which type of material we have to utilize to design the magnetic system. Magnetic circuits with and without air gaps, with single winding and multiple windings, how to analyze the circuits and how to design it. Finally, the design of electromagnet with respect to the area product of the magnet. We can see at the right side image how to select the core area product and the number of turns with respect to the coil, and how to select the gauge, and how to calculate the efficiency, losses and other performance parameters, and force equations involved in the magnetic circuits also we will see, and the design example. In week 3 we will discuss the principles of rotating magnetic machines based upon the electromagnetic principles. How to realize the electrical machines we will discuss in details. The working principles for induction machine like mutual induction. For synchronous machines it will be based upon the magnetic locking. For switched reluctance machines it will be attraction of electromagnet and iron piece. To realize any type of machine we require the two magnetic fields. Based upon the attractions and repulsions of these two fields will generate a torque. So, how to create these two magnetic fields? We require some kind of windings. So, for a given winding, what is the MMF distribution and what type of magnetic fields will be involved, whether it is rotating magnetic fields or stationary fields, we will discuss in detail. In week 4 and week 5 we will discuss in detail about the type of windings, DC mission windings and AC mission windings with respect to lap winding, wave winding, integral slot or fractional slot or full pitch or short pitch, etc. we will discuss. And one lecture we will discuss how to make the rewinding of electrical machine with respect to the practical aspect. We can see right side single coil. After placing all coils inside the stator core and after completing the complete stator winding, we can see here Then winding design for variable pole machines also we will discuss. In week 6 and week 7 we will focus on the generalized theory for design of electrical machines. We can see here this is a machine. How to select the volume product for a given application, for a given torque or for a given power, how to select the volume, okay, volume of the machine, and then type of a rotor or type of a stator, and laminations data, and magnetic flux densities at various parts of iron, and electric loading with respect to the surface current density. All those things we will discuss in detail. To find the sizing equations, we will see here d square L volume product equation. Here d is nothing but inner diameter of the stator. See here the d square L product involves with respect to the stator inner diameter or air gap diameter and length of the stator core, and this is the length of a stator core and inner diameter of the stator core. So, based upon this thing, the sizing equation with respect to the d square L product will realize, and then d cube L product is nothing but by considering the inner diameter as well as outer diameter of the stator and length of a stator, how to find the volume of a machine. In a d cube L product, we are considering the stator geometry also. Then followed by volume and power density equations and different standards we will discuss. In week 8, we will see the in detail analysis with respect to the design of induction machine, like this is the stator core. So, how to select the laminations and what is the slot depth and slot dimension, slot area, and which type of winding we have to utilize it, and stator resistance and coil length and which type of winding, etc. we will discuss in detail. And then rotor core design, similar to the stator, which type of rotor we have to utilize it, whether it is squirrel cage or slip ring or permanent magnet rotor, and what are the dimensions and other performance parameters we will discuss in detail. We can see here one stator lamination and rotor lamination. So, how to select the slot depth, slot area and dimensions and flux densities at the different parts of iron, flux density at the back iron, flux density at the teeth, flux density at the air gap. So, all those things we have to consider while designing the electrical machine. In week 9, we will discuss the performance parameters of an induction machine with respect to the leakage inductance, magnetizing inductance, efficiency calculations with respect to the iron losses, copper losses, and then mechanical losses, stray load losses we will see in detail. Week 10 and week 11 we will discuss about the special machine design. Based upon the induction machine design equations, how to make it generalized and how to design the switch reluctance machine. And the principle of switch reluctance machine we can see here. Stator side we have the electromagnet, rotor side simple iron piece, this is the iron piece based rotor. If we will excite A phase, rotor will be automatically aligned towards the A phase. If we will excite B phase, rotor will attract towards the B phase. Like one side electromagnet is there, other side simple iron piece is there. Based upon the attraction and repulsion it will work, right. The same principle here also. Then the stator and rotor design of a SRM with respect to the sizing equations and volume product and slot dimensions and everything, machine parameters, efficiency calculations we will discuss in detail. In week 12 we will discuss about the thermal and insulation design. In a practical system there will be a loss So, these losses will be dissipated in the form of heat, right. So, how to consider these losses to make the system, how to manage the thermal system for a given type of a machine. We can see here which type of cooling methods are there, whether it is natural cooling or forced cooling. For example, here fan based cooling we can see here in this image, and different type of fan arrangements we can see here in this image. So, for any type of machine, as per the standards, how to design the thermal design and thermal equivalent circuits of a machine we will discuss in detail. The reference textbooks for this course are Thomas A. Lippo, Introduction to AC Machine Design, and Design and Specifications of a Direct and Alternating Current Machinery by Alexander Gray, and R. Krishnan book for Switched Reluctance Machine Design, and Juha Parhanan for Design of Electrical Machines, and a course on electrical machine design with respect to the A.K. Sahane. Thank you. With this I am concluding the introduction lecture. The outcome will be how to design a electrical machine for any type of application with respect to the sizing equations, with respect to the given torque or power. Thank you.